Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and whoa, I am excited to do this video with you. We are now in our series neck deep, into paper 2. In this specific section, we are looking at analytical geometry. Now, analytical geometry is the one section of work where there's a lot of intricate, small little things that come together. Remember, in this series where we're looking at exam preparation, we are specifically working through the 2021 Maths Paper 2 from the Department of Basic Education. So what I'm going to ask you to do is look at this sum. Read it in the diagram. There's A, B, and C, etc. Read it through. Take your formulas from the formula sheet. I've took an excerpt from your formula sheet and try it yourself. Before I go and do it, you try and do it yourself. So if you look at this, I want to go through this, and I'm maybe going to go into a lot more detail than you're used to, but I want to show you how I analyze a question like this one. So if I look at this question, and I'm going to read it through step by step. In the diagram, you've got A, -2, 10, B, which is K, K, and C, 4, 2. Okay? The first thing that I notice at B is that it is K, K, which means the X value and the Y value is exactly the same. That is a very important little thing for later on. Okay? They are the vertices of triangle ABC. Line BC is produced to H and cuts the x-axis at 12, 0. Important. Okay, we're going to also look at that. So it's the x-intercept of the line BCEH. Then as well, they tell me that AB and AC intersects the x-axis. So at both of those places, F and G, Y is 0. Kind of important, but we are not exactly sure at the moment where this is going. So when I look at this, they also say I've got an angle of inclination. So the moment I read angle of inclination, I know I've got to go to m equal to tan theta. And that is how I break it apart. Now, I want to just get something clear here. Something that you must be familiar with. They told me that BCEH, they all lie on a same line, so they are collinear. That is very important because collinearity means the gradient between BC is the same as the gradient between C and E. Lot of information, and this is fine. Let's take this information now and analyze the actual question. So the first question they ask you is calculate the gradient. Now what I love to do, matriculates, is literally take this bit of information, break it apart, and then say, okay, how can I get gradient? Well, gradient, I've got 4 options. Change in y over change in x, parallel lines, perpendicular, or m equal to tan theta. There is a 5th one if you're in matric. There is a 5th one, derivatives, but I'm not going to look at derivatives at all, okay? Not because it can't be asked, but not necessarily easy in paper 2. So when I look at the information and they're asking me for BE, I'm going to think of, you know what, I don't have B, but I do have C and E. So I'm going to think of change in Y over change in X. So that is going to be my gradient. 0 minus -2, 12 minus 4, which gives me a gradient of 1/4. Now, does it make sense? What do I mean, does it make sense? Please, I'm not saying that, if did I substitute in right? I'm asking, does it make sense? In other words, if I look at the sketch, does a gradient of 1/4 make sense? Well, how do I know it makes sense? Well, is it positive or negative? The gradient is positive 1/4, which means my line must be sloping up. Does that make sense? Yes. Why I'm asking you this is a safety check. That if you got, for instance, negative 1/4, you know you made a mistake. Okay, let's go back to that. The next question, 3.1.2. They're asking you the gradient of AB. Now, I'm looking at that inclination because they gave me the inclination angle, the angle between the positive side of the x-axis, okay? So from the right of that point on the x-axis to the line. Therefore, I'm just going to substitute in. And my approximate answer is 7. So then, please remember to write this on the sketch. Indicate it on the sketch. Don't just move on. Indicate, then move on. Let's look at the next question. The next question that is asked is determine the equation of BE. Oh, but that's easy because I just go and I've already got the quarter there. So all I'm going to do is I'm just going to substitute now the set of coordinates, 12,0. I choose that because the y is 0, man. I love it when there are zeros. It makes my life so much easier. Substitute it in and solve for c. So c is -3. Does that make sense? Well, yes, because it cuts on the negative y. Okay? It cuts on the negative y, so it does make sense for me. Now let's look at the next bit of information. Okay? Question 3.3. This one was not on the second slide, so you can quickly hit the pause button, try and do it yourself, and then hit the play button again, and then you can continue further. So question 3.3, it says, first of all, get the coordinates of B, where K is, of course, smaller than 0. Now, what I love to do is, let's look at what we got earlier. What did we just get in 3.2? Well, I've got the line Y, I've got the line of BE. So all I'm going to do is, I'm going to say, well, if B is on BE, well, I'm going to make the X value K and the Y value K. And I'm going to solve for K. So, getting K alone on one side, I've got times by 4 over 3 times by 4 over 3. K is -4. Does that make sense? Well, yes, because the X values are on the negative side and the Y values are on the negative side. Yes, it makes sense. Please remember to always check, does it make sense? Look, ladies and gents, there are many options. You could use the gradient of CE and make it equal to the gradient of BC and solve for K. That would work just as well. It is your choice. Go and try it and see whether you get the same answer. Remember my 70, 80s, 90 percenters? You need to have 2 options available in your mind to complete sums like this. Now let's look at 3.3.2. Now 3.3.2, it asks us to calculate the angle A. So what I love to tell my students is, angle BAC touches which lines? That angle is in between the lines AB, which I've already colored in red for you, but it also touches which other line? It touches AC. This means I'm going to need those two lines to get the angle A. Not just any part of the two lines, but specifically their inclination angle. So if I want to get alpha, which I now set as A, okay, angle A is alpha, I'm going to have to work with angle AFG because that's the inclination of angle AFB, and also the inclination angle theta, which is with AGC. How we exactly work with it, that will be a later on problem. But get this when you are doing analytical geometry. Whenever I've got the angle between two lines, you know those two lines, inclination angles I'm going to need. Even if you don't know how to finish the sum off, at least you'll be able to score a few marks. But let's try and finish the sum off. To get theta, I need the gradient. Oh, but that's easy. Remember the four options. Your first option is change in y over change in x. Well, that I can do. So I'm going to look at that triangle to eventually solve alpha. So let's start by getting theta. The gradient of AC, 10 minus negative 2 over negative 2 minus minus 4. The gradient of negative 2, that makes sense because the graph is sloping down. I'm going to substitute this into negative 2 equal to tan theta. And if I solve theta, okay, I'm going to get an answer of 116,57. Remember, I'm adding the 180 degrees because there's a negative gradient. Now my question is, if I've got theta and I've got the 81,87, how do I get alpha? Well, theta is the 81,87 plus alpha. Why is that, ladies and gents? Why? Because it is the exterior angle of triangle AFG, which means that alpha is the 116,57, which is theta, minus 81,87. And this means that alpha is 34,7. Please, ladies and gents, if you are unsure about this, try it yourself first. Again, go back and look, why did I get the 116,57? How do I use it to get alpha? Now, some students will say, but sir, I would rather want to calculate that angle there. Go for it. And then use interior angles of a triangle. Man, that's perfect. It's longer, but it's perfect. You must find something that works for you. Now let's look at question 3.3.3. The coordinates, now the question is, they're looking for the coordinates of the point of intersections of the diagonals of parallelogram ACES. Okay? ACES. But when we look at this specific sum, it is a bit of an interesting one because S is nowhere on the actual sketch. So what I'm going to do is I'm going to put S in there so that I have the information on the sketch. So they say ACES is a point, is a what? Is a parallelogram, okay? So the word parallelogram then signifies that I've got the shape where the opposite sides are equal. Let's not forget that they are also parallel to one another, okay? So what else do I know? Well, the diagonals bisect one another, okay? So in other words, the midpoint of the one set of diagonals is the same as the midpoint of the other set of diagonals. So if we are asking for where the diagonals intersect one another, there's our word, intersect one another, I must just get the midpoint of AE. That's all I'm looking for. So all I'm going to do is I'm going to go to my formula, okay, and go and find, let's call it M, which is the midpoint between A and E, using my midpoint formula. As simple and as easy as that. But now the question that I want to ask you is, what if they asked you to actually determine S's coordinates? Now you can go the long route by using midpoints or formulas like that, and it wouldn't be wrong, but let's look at an easy way of determining S's coordinates. I'm just going to look at movement. In other words, if they ask me for the S's coordinates, so many S's in that word, sorry, my tongue is slurring. I'm going to look at the movement from C to E and replicate that to get from A to S. So let's look at the movement from C to E. So if I look at that, first of all, to go from 4 to 12, I go forward 8 units. And secondly, I go from -2 to 0, so I go up 2 units. I'm going to replicate that. So to go from A to S, I'm going to go forward 8 units. So I'm going to take the x value, the -2 of A, and add A to that, which gives me 6. And I'm going to say, okay, 2 units up. So I'm going to take the y value, the 10, and I'm going to add 2 to that, which means S's set of coordinates is 6, 12. And then ACES is a parallelogram. Wow, ladies and gentlemen, this was awesome. But the question is actually not done. In our next video, I'm going to specifically look at question 3.4. Now, there's a reason why. Question 3.1 up to 3.3 is just requiring grade 10 and 11 analytical geometry, while 3.4 goes over towards circles. So I want to keep that for a separate video. So don't run away. Hit the next button and look at the next video specifically about circles. This is Mr. VG signing out. Have a beautiful and amazing rest of your day. I'm looking forward to having you together for our next video. Keep well. Cheers.